Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Today in this video, I am going to start Unit 2 of subject Fundamentals of Mechanical Engineering and Mechatronics, KME 101T. So, Unit 2 is basically related to thermal part of mechanical engineering, application of thermodynamics. So, the first topic which is related to that application is IC engine, internal combustion engine. Okay. So, first of all, it is necessary to understand what we basically means by engine. So, engine generally termed as heat engine in thermodynamics. So, it is a machine which converts heat energy supplied to it into mechanical work. So, whatever the energy we are getting, we are receiving from burning of fuel, that has to be converted, that will be converted into useful mechanical work by heat engine. So, heat engine is that system where the heat energy from burning of fuel may be any of kind. So, that energy by some means getting converted into useful work. So, this is what the heat engine is basically. So, we must be very clear. And how the energy from burning of fuel comes out? Because generally the fuels are hydrocarbons and the combustion of hydrocarbon is exothermic reaction, means a large amount of energy will be released whenever we are combusting some fuel. Okay. So, on the burning of fuel, large amount of energy will be released by some mechanism, generally 4-bar mechanism is used. We can convert that energy, that heat energy into useful work. So, this is what the function of heat engine. Heat engine are basically classified in two ways on the basis of combustion, where the combustion is taking place. These are classified as internal combustion engine and external combustion engine. So, by the name it is very clear, internal combustion engine means the burning of fuel takes place inside the cylinder. Okay. So, in IC engine, combustion of fuel takes place inside the engine cylinder. So, generally we check with diesel engines, petrol engine, gas engines, which we are generally using in our automobiles. These are generally termed as IC engine. Here the combustion of fuel exactly takes place in the cylinder, not outside the cylinder. Whereas, if I talk about external combustion engine, where the combustion of fuel takes place outside the cylinder. Okay. So, the fuel is burning outside, the energy of that fuel is transferred up to the cylinder and then that has to be converted into useful mechanical work. So, generally the steam engine, steam turbines, these are the cases. Here the working fluid, steam, is generated not inside the cylinder, outside, generally in the boiler. So, this is the main difference between the internal combustion engine and external combustion engine. Now, our topic is internal combustion engine. So, how the classification of IC engine takes place? Okay. So, how the classification of IC engine? Okay. So, first we can classify on the basis of type of fuel used. Petrol engine, as we all know, diesel engine, yes, we know, gas engines, nowadays we are using, bi-fuel engine also we are using. Okay. We are getting the combination of engine. So, okay. According to the number of strokes also, okay, that I will be defining 4-stroke and 2-stroke. What do we mean by stroke? So, on the number of strokes per cycle, we can also classify the IC engine. There are some more classifications, okay, according to the method of ignition: spark ignition, compression ignition. Obviously, the fuel is inside the cylinder, it has to be burnt. So, by which means we are burning? Either by using the spark or producing the spark, or by the self compression, the temperature is increased. Okay. So, compression and spark ignition, by which means the ignition is taking place. According to the cycle, these are the cycles. Okay. So, Otto cycle generally used for petrol engines, diesel cycle for diesel engines, dual cycle also be used somewhere. So that definitely here only we are classifying and we are naming only the different type of classification, but definitely in coming videos these all terms will be discussed. Okay. Classification on the basis of the arrangement of cylinder, how the cylinders are arranged, vertical, horizontal, line, radial, V engine. Okay, this is one classification. According to the type of cooling, obviously whenever we are burning the fuel inside the cylinder, large amount of energy releases. So large amount of energy releases, so definitely it causes the temperature rise in the cylinder. So it is necessary to cool the engine. So sometimes the air cooled engine are sufficient to maintain the temperature, but sometimes we have to go for water cooled engine along with some coolant. So on the basis of cooling system we can also classify the engine. Okay. So earlier slides we were observing about what? We were observing about the different type of IC engines on the basis of fuel, on the basis of strokes, on the basis of type of cooling, on the basis of cylinder arrangement. Now we must be well aware about the IC engine terminology. Okay. So bore, top dead center, bottom dead center, what basically this is. So in IC engine we are mainly concerned about the cylinder and piston arrangement. Cylinder and piston arrangement. So let me draw one simplest diagram. Okay. This is what I am trying to draw, the cylinder and piston arrangement. Okay. Okay, if I say this is cylinder and this is what the piston. Okay. So now I am coming to all the basic terminology. Okay. Here there will be some arrangement for valves. Okay. So here I am now coming. Bore. Bore is basically what? It is the inside diameter of the cylinder. It is the inside diameter of the cylinder. It means this is the bore. Okay, inside diameter of the cylinder. I can indicate it with D. Okay. Then bore. So inside diameter of the cylinder. Now the second term is top dead center, TDC. So the extreme position reached by the piston at the top of the cylinder in the vertical engine, or generally I can say it's the nearest position of piston from cylinder head. Okay. Now I am coming to the second point or third point also, the bottom dead center, BDC, the extreme position reached by the piston at the bottom of the cylinder in vertical engine. It means the farthest position of the piston from cylinder head. Now what does it mean? ये तो चला गया इसका यार, वो जो इस पे वो थी डायग्राम. अच्छा वो चला जाता है. ओके. तो फिर मैं इसके बाद से यहां से मैं दोबारा कर लेता हूं. ठीक है ना, वो दोबारा बन जाएगा. ओके. So on earlier slides we were discussing about the classification of engines on the basis of type of fuel used, on the basis of cycle, on the basis of type of ignition, on the basis of what? On the basis of position of the cylinder, on the basis of cooling. So these are the basic classification. These are the basic classification of IC engine. Now it is necessary, when we are going into the detail, it is necessary to understand the terminology. So the basic terms related to IC engine, bore, top dead center, bottom dead center, and many other terms. So first of all, before going into the detail, I would like to draw one diagram. Okay, I am trying to replicate the cylinder and piston arrangement. Okay, so here I am trying to draw the cylinder and piston. Okay, okay, this is what so this is, I can say, cylinder, and this is what the piston. Okay, very rough sketches, but for understanding it is necessary. So the first term is bore, the inside diameter of the cylinder. So if I consider this as a cylinder, then inside diameter is this much. So this is the bore, inside diameter. Now the second term is top dead center. So what is written over here? The extreme position reached by the piston at the top of the cylinder in vertical engine. In general, I can say it is the nearest position of piston from cylinder. The third is the bottom dead center, BDC, the farthest position of piston. Or if I talk about the vertical engine, the extreme position reached by the piston at the bottom of the cylinder. It is the farthest position. Now, what these two terms mean? Okay, obviously this piston will reciprocate in this cylinder. So the nearest, this is the position of cylinder head. So the nearest position which piston can reach. So obviously, suppose up to this point it is reaching. Okay, so this will be treated as top dead center. This end, top dead center. Dead center means now it can't move ahead of this. Okay, it has to come back. Okay, so this is the top dead center. Bottom dead center, farthest position. Now the piston is reciprocating. So when it is going away from the cylinder head, it can reach up to this point. So this is the bottom dead center. Again it has to come back. While reaching up to this point, the piston has to go back towards the TDC. So this is what the meaning of TDC and BDC, top dead center and bottom dead center. Stroke, the length covered by piston, the distance covered by piston from TDC to BDC. So the nominal distance traveled by the piston in the cylinder between the extreme upper and lower positions of the piston, TDC and BDC. What does it mean? It means from here to here. This will be termed as stroke. This will be termed as stroke. So 4-stroke engine, 2-stroke engine we talk about. So when we will discuss the working, then definitely you will realize. So stroke means the movement of piston from TDC to BDC. What next? Compression ratio. It is the ratio of maximum cylinder volume to the clearance volume. Compression ratio. Normally the mixture of air and fuel, or the air enters in the cylinder at atmospheric pressure. But at atmospheric pressure, it is not possible to make the burning possible. So it has to be compressed. The fuel or the air fuel mixture has to be compressed. So the maximum amount of compression which is possible, this is what known as compression ratio. So basically it is the ratio of maximum cylinder volume to the clearance volume. Maximum cylinder, I am coming to this point, but first I would like to cover cylinder volume. What it is? It is the sum of swept volume and clearance volume. Now what are these terms? Swept volume and clearance volume. So here we are observing from this point to this point, this is the stroke length. So the volume covered by piston, volume covered by piston, volume swept by piston from TDC to BDC. This is what known as swept volume or stroke volume. Some volume has to be left. Some volume of cylinder has to be left. For what purpose? For the purpose of opening of valves, for the purpose of compressed fluid. So that is what known as clearance volume. Okay. So total cylinder volume is the sum of clearance as well as stroke volume. And compression ratio, it is the ratio of maximum cylinder volume. Maximum cylinder volume, it means the sum of Vs and Vc, swept and clearance volume, to the clearance volume, because maximum possible compression is up to clearance volume. So minimum volume which is available in cylinder, that is clearance volume divided by maximum cylinder volume divided by clearance volume. That can be the maximum compression ratio available. Okay. Now the swept volume, already discussed, it's the volume space generated by the movement of piston from one dead center to another, means from top dead center to bottom dead center. Okay. Clearance volume, it's the space in the cylinder when the piston is at top dead center. Okay. So already discussed. Okay. So this is what the different type of volume. So this is the basic terminology related to IC engine, cylinder and piston arrangement. Now coming to the point, what are the main parts? Cylinder, piston, piston rings, connecting rod, crank and crankshaft, valves, flywheel, crankcase. Okay. So cylinder, this is what the cylinder, this area is cylinder. Okay. Piston, this is piston written over here. Piston rings, piston and cylinder both can't be of same size. It is not possible to reciprocate for the piston in the same size of cylinder. So definitely there is some allowance between the piston and cylinder, but that allowance has filled with the help of piston rings. So this is piston rings. Connecting rod, okay, crank and crankshaft, crank and crankshaft. Okay, this is crank which is rotating in the crankcase, and crankshaft, the shaft which is getting the rotation from the crank. Valves, these are the valves. These are the valves. Flywheel, okay, flywheel, there is arrangement because we are getting power only in one stroke of the engine. Okay, so rest of the power will be delivered by flywheel for the rest of the strokes. Crankcase, the space where crank rotates. Okay, so this is what the basic parts, basic components of IC engine. So one by one I will be discussing the working of each and every part. Cylinder, the part of the engine where fuel is burnt, obviously the part of the engine. So this is the reason where the fuel is burnt and the power is developed. Inside diameter is known as bore, already discussed. This is what the bore. So this is the part where the burning of fuel takes place. Piston, okay, this is the piston. This is piston, close fitting hollow cylinder plunger moving to and fro. It is reciprocating. It is reciprocating, and its reciprocating is made by 4-bar mechanism. Okay, so this is the piston which is causing the compression of air, fuel or air. Okay, so piston. Function, power developed by the combustion of fuel. Obviously when the burning of fuel will occur and the large amount of energy will be released, so that energy will be pushing the piston. So the power developed by the combustion of fuel is transmitted by the piston. So it is transmitted to the piston, then definitely from the reciprocation of the piston it will be transferred to the connecting rod. Then connecting rod maintains the rotation of crank and crankshaft. So this is what the function of piston. Another is piston rings. So as I already told, the piston and cylinder both are not of same size. So there are some metallic rings provided circumferentially on the piston. The function of these rings to maintain the gas tight joint, no leakage, because if the leakage is there then combustion will not occur properly, there will be the loss of energy. So piston rings, metallic rings inserted into the grooves. So these are the grooves. So here on that piston rings are mounted. You can see the piston if you have observed on the mechanic. There are some slots, circumferential slots on the piston. So where at that place we place the piston rings, and the purpose is to maintain the gas tight joint. Okay. Connecting rod, link that connects the piston and crankshaft. Connecting rod, crankshaft and piston, it connects this. It converts the rectilinear motion, obviously the reciprocating motion of piston, into the rotary motion of crankshaft. So this is what the connecting rod. Because of the burning of fuel, piston is pushed, connecting rod will in the GPM, general plane motion, and because of the general plane motion of the connecting rod, the crank will rotate and definitely the crankshaft ultimately. So this is the crankshaft through which the power is transmitted to the wheels. Then crank and crankshaft. So crank is the lever, that is the connection between the crankshaft and piston rod. Okay, and valves. valves. Obviously, there are the spring loaded valves. These are also connected with the crankshaft. So the motion of the crankshaft controls the opening and closing of inlet and exhaust valve, and here is the arrangement of cam which controls the opening and closing. Okay, so these are the devices which control. For the what purpose the valves are there? To allow the inflow and outflow, inflow of air and fuel, and outflow of exhaust gases. So obviously by certain positions both valves remains open, both valves remains closed, one remains open, one remains closed. So this is what the valves, the function of valves. Flywheel mounted on crankshaft to maintain the uniform rotation of the crankshaft. As I already told that only in one stroke we are getting the power from the engine. Rest 3 strokes are to be controlled, are to be maintained by energy of flywheel. So this is what the flywheel. Basically flywheel is a rim type of arrangement where the maximum of its mass is on its circumference. So it is having greater moment of inertia. So it is having the capacity to store the kinetic energy of rotation. So that's the way it supplies the energy. So flywheel. Okay, so this is what the crankcase, the enclosure for crankshaft and sump of lubricating oil. Obviously here this is the sump of lubricating oil. Here the lubricating oil is there for maintaining the proper lubrication of the engine. Okay, here the crank rotates, and when this connecting rod is coming down, so the big end of the connecting rod takes a dip into that sump, gets some lubrication and supplies to the other part. So this is what the function of crankcase, enclosure for crankshaft and sump for lubricating oil. Cylinder block. So it's the main block of the engine. It contains cylinder accurately finished to accommodate piston. So basically cylinder block where the so the cylinder block houses what? Crank, camshaft, piston and other engine parts. In water cooled engines the cylinder block is provided with water jackets for the circulation of cooling water. The material used for the cylinder are grey cast iron. So cylinder blocks. So this is the diagram, cylinder block which we generally see. So outer case of the cylinder and piston arrangement. So this is what the cylinder block. Okay, so cylinder block look like this. So from this I can say the main basic terminology and the function of different parts of IC engine I have covered in this particular video, which is required for the further discussions. So now whenever we are using the term keystroke, top dead center or the flywheel, so that will be well understood in the future. So this is what the purpose behind discussion and the video of this particular video. I hope you can understand the basic terminologies and the main functions of main components of IC engine. So thank you very much for watching the video. Thank you.